channel. I'll be doing calorimetry exercise 11A question number 8 onwards. So question number 1 to question number 7 have been already done, and the link will be provided in the description below. You can check out that video. So without any further delay, let's start with it. So for 8th question, 0.5 kg of lemon squash at 30 degrees Celsius is placed in a refrigerator which can remove heat at an average rate of 30 joules per second. So we can clearly see that mass is 0.5 kg. The temperature is 30 degrees Celsius, the initial temperature. Is placed in a refrigerator which can remove heat at an average rate of. Now, removing heat at a rate of means what? It means power, because you can see here it is joule per second. Joule per second is nothing but work done divided by time, which is nothing but power. So we can consider this as power, that is 30 watts. How long will it take to cool the lemon squash to 5 degrees centigrade? So the final temperature given is 5 degrees Celsius. Specific heat capacity is given as 4200 joules per kg per Kelvin. So we can find out the change in temperature. That's going to be 30 minus 5. So that is T2 minus T1, 30 minus 5, that is 25 degrees Celsius, which can also be written as 25 Kelvin. If you want to understand why Celsius is equal to Kelvin, you can see the previous video of calorimetry exercise 11A. So power is 30 joule per second, which is nothing but 30 watt, as I told you before. Mass is 0.5 kg. Now Q is equal to mc delta T. Now Q is equal to mc delta T. Q can be written as P into T, because power is work done by time. If time goes to the other side, we get work done is equal to power into time. And work done also comes in joules, and heat also comes in joules, is equal to M into C into delta T. So we know the values of most of it, we just do not know the value of T. So M is 0.5. It is given in the question, you can see here. Specific heat capacity is given in SI unit only, that is 4200 joules per kg per Kelvin. So I have written 4200 joules per kg per Kelvin. Delta T, we just found it out to be 25 Kelvin, so I wrote it as 25 divided by P. So P is given in the question as 30 joules per second, which is nothing but 30 watts. So divided by 30. When I multiply all these three, I get it as 52,500 divided by 30, which gives me 1750 seconds. You can definitely leave your answer here because second is the SI unit. But since your textbook has it written in the form of minutes and seconds, I converted it to minutes and seconds. So for that, what I do is I divide 1750 divided by 60. That gives me 29.16 minutes. Now 29.16 minutes can be written as 29 minutes plus 0.16 minutes. Now 29 minute, I keep it as 29 minutes only. It will be 29 here plus 0.16 into 60 seconds. So 0.16 is converted to seconds. So 0.16 into 60 gives us 10. Approximately we get it as 10. So we can write it as 29 minutes and 10 seconds. Sorry about the mistake. Here it will be 29. Please bear with it. Coming to the next question. A mass of 50 gram of a certain metal So mass is given as 50 grams. Remember, this is not in SI unit. At 150 degrees Celsius is immersed in 100 gram of water at 11 degrees Celsius. So we can consider this as the temperature of the hot body, and we can consider this as the temperature of the cold body. The final temperature noted is 20 degrees Celsius. So this is the final temperature. Calculate the specific heat capacity of the metal. Now, specific heat capacity of water is given in the question, that is 4.2 joule per gram per Kelvin. So I have to tell you some things here. The final temperature, or the temperature of the hot body, the temperature of the hot body and the temperature of the cold body you can see here. So temperature of the hot body is 150 degrees Celsius. Temperature of cold body is 11 degrees Celsius. Final temperature given in the question is 20 degrees Celsius. So you can see the final temperature comes in between the hot body temperature and the cold body temperature. So when it comes exactly in between the two, we can tell that for the hot body, the change in temperature will be hot body temperature minus the final temperature, and for the cold body, change in temperature will be final temperature minus cold body temperature. So please remember this, what I told you just now. For hot body, change in temperature will be hot body temperature minus final temperature, and for the cold body it will be final temperature minus cold body temperature. So I have just taken few variables here. T suffix H denotes temperature of hot body. We took it as 150 degrees Celsius. Temperature of cold body, we took it as 11 degrees Celsius. Final temperature is 20 degrees Celsius. M suffix C is mass of water, that is 100 grams. M suffix H is mass of metal, that is 50 grams. Now I have taken suffix H because metal is a hot body, so M suffix H denotes mass of hot body, and M suffix C denotes mass of cold body, that is water, that is 100 grams. Now if you notice one thing, the specific heat capacity of water is given in joules per gram. So we need not convert gram to kg, you can keep it in grams only. Now coming to the principle of calorimetry, heat lost by the hot body will be equal to the heat gained by the cold body. Now we actually use the formula mc delta T is equal to mc delta T, which is nothing but mass of hot body for the hot body, specific heat capacity for the hot body, into delta T for the hot body, that is change in temperature for the hot body, which is just told you it will be temperature of the hot body minus final temperature is equal to, we will write mc delta T for cold body, that is mass of cold body into specific heat capacity of cold body, and delta T for the cold body will be final temperature minus cold body temperature, as I told you. So that is Tf minus Tc. We just substitute the values. Mh is 50, so that comes as 50. Ch, we need to find the value of Ch, that is the specific heat capacity of the metal, into Th is 150 Celsius, so I have written 150, minus Tf, that is final temperature, is 20, so I have written it as 20, is equal to mass of cold body is given in the question as 100, so I wrote it as 100, into Specific heat capacity of water or cold body is given as 4.2 joules per gram per Kelvin. I have converted it to joules per kg per Kelvin, but you need not do this. Into temperature, that is final temperature, that happens to be 20, minus temperature of cold body, that is 11. So I can cancel this 50 and 100, so it becomes 2 times 50 to the 100, and I multiply this here and I do the calculation. So 20 minus 11 gives me 9. So 2 into 4.2 into 9 gives me 75.6, and 150 minus 20 gives me 130. So 130 CH is equal to 75.6. So CH will be equal to 130, goes to the other side, denominator. So that is 75.6 divided by 130. So I get it as 0.582 joules per gram per Kelvin. This is a very important question. Please go through it again. If required, rewind the video and see the solution again. So getting into the next question of exercise 11A, calorimetry ICSE 10th. 45 gram of water at 50 degrees Celsius in a beaker is cooled when? So 45 gram of water at 50 degrees Celsius, that means what? Mass of hot body is given as 45 grams and temperature of hot body is given as 50 degrees Celsius. Is cooled when 50 gram of copper at 18 degrees Celsius. So mass of cold body is given as 50 grams. Temperature of cold body is given as 18 degrees Celsius is added to it. The contents are stirred till a final constant temperature is reached. Calculate the final temperature. So we basically need to find T suffix F. So specific heat capacity of copper is given in the question, that is C suffix C, that is C of cold body, that is 0.39 joule per gram per Kelvin, and specific heat capacity of water is given as C of H, that is specific heat capacity for hot body, that is 4.2 joule per gram per Kelvin. Now you have to notice one thing here, that is mass is also given in grams, specific heat capacity is also given in grams. So you need not convert anything. So we directly write by principle of calorimetry, heat lost by the hot body is equal to heat gained by the cold body. Now delta T for hot body, as we discussed in the previous question, is temperature of hot body minus final temperature, and delta T for the cold body becomes temperature of the final temperature minus temperature of the cold body. So I just write MC delta T, that is mass of hot body into specific heat capacity of hot body into TH minus TF is equal to mass of cold body into specific heat capacity of cold body into TF minus TC. So we get it as 45, that is mass of hot body, which is given here 45, into 4.2, that is specific heat capacity of water, you can see here it is given in the question, into 50 minus TF, because temperature of hot body is given as 50 degrees Celsius here. So is equal to mass of cold body is given as 50 grams into 0.39 is the specific heat capacity of copper, or specific heat capacity of the cold body, you can say, into Delta T for the cold body will be final temperature minus cold body temperature, that is TF minus 18. So 45 into 4.2 gives me 189. 50 minus TF, I write it as it is. 50 into 0.39 gives me 19.5. TF minus 18, I write it as it is. Now I just multiply 189 into 50, that gives me 9450, minus 189 into TF gives me 189 TF, is equal to 19.5 into TF gives me 19.5 TF, minus into plus is minus, so minus of 19.5 into 18 gives me 351. Now I take 351 to the other side, so we get 9450 plus 351, which I write it here, and this minus 189 TF, I get it to the other side, so we get 189 plus 19.5 TF is equal to 9450 plus 351. When I add these two, I get 208.5 TF is equal to, I just add these two, so we get it as 9801. So TF is equal to 9801 divided by 208.5. So which gives me 47 degree Celsius. That means the final constant temperature of the mixture is 47 degree Celsius. The calculations can be a bit long. Please practice the sums. It will be easier for you to do it. Getting to question number 11 of calorimetry, exercise 11A of ICSE 10 standard. 200 gram of hot water at 80 degrees Celsius. That means what? This is the hot body. So mass of hot body is given as 200 grams. Temperature of hot body is given as 80 degrees Celsius. Is added to 300 gram of cold water. So mass of cold water is given as 300 grams. Temperature of cold water is given as 10 degrees Celsius. Neglecting the heat taken by the container, calculate final temperature of the mixture of water. Specific heat capacity, since both are water, is given as 4200 joules per kg per Kelvin. Now you need to notice one thing here. Specific heat capacity is given in joules per kg Kelvin and the mass is given in grams. So you have to convert either of them. So you can see I have not converted, but we have done something. I will tell you. mH, that is mass of hot body, is 200 grams as I told you. Mass of cold body is 300 grams as I told you. By principle of calorimetry, heat lost by the hot body is equal to heat gained by the cold body. So that can be written as mc delta T for hot body, that is mHch delta Th, is equal to mc delta T for cold body, that is mccc delta Tc. So now what I do is I write mHch delta T for hot body will be what? It will be temperature of hot body minus final temperature as I told you before, and delta T for cold body will be temperature of final temperature minus temperature of cold body. So we get it as mccc Tf minus Tc. Now if you notice one thing, I have cancelled CH and CC. The reason I have cancelled CH and CC is the material is the same, that is, it is water. So for water, we have the specific heat capacity as 4200 joules per kg per Kelvin. So instead of making the calculations difficult, what I have done is I have just cancelled the specific heat capacity from the equation because the material remains the same. You can also do this if material is the same. So mH is given as 200, mass of hot body, temperature of hot body is 80 minus final temperature is equal to 300 into final temperature minus 10. Double zero cancels on the left side and right side. 2 into 80 gives us 160 and 2 into TF gives us 2TF with a negative sign is equal to 3TF minus 3 into 10 gives me minus 30. So I get this 2 to the other side, that is minus 2TF to the other side. I get 3TF plus 2TF, that is 5TF. And this minus 30 comes to this side and I get 160 plus 30, that is 190. So TF will be 190 divided by 5, that is final temperature will be 38 degree Celsius. It was an easy question if you have understood. So you can go through the question again. Coming to the question number 12th of ICSE 10th calorimetry exercise 11A. The temperature of 600 gram of cold water rises by 15 degrees Celsius when cold body mass is given as 600 grams. We will speak about this 15 degrees Celsius in a while. When 300 gram of hot water, so mass of hot water is given as 300 grams, at 50 degrees is added to it. So temperature of hot water is given as 50 degrees. What was the initial temperature of cold water? Now this question repeats many times in board exams. So this is very, very, very important, where temperature of hot body is given and temperature of cold body is not given in the question. Mass of cold body is given, mass of hot body is given, specific heat capacity, there is no mention about it. But we can see one thing, it is given as water. So for water, it is 4200 joules per kg per Kelvin or 4.2 joules per gram per Kelvin. So I would consider the temperature of cold body to be X. Final temperature, as it is told in the question, rises by 15 degrees Celsius. That means the final temperature is X plus 15. Temperature of hot body, as it is given directly in the question, is 50 degrees Celsius. Now by principle of calorimetry, M suffix C, that is mass of cold body, into C of C, that is specific heat capacity of cold body, minus delta T for cold body, that is TF minus TC, is equal to MH CH TH minus TF, that is delta T for the hot body. So I have written hot body on the right hand side and cold body on the left hand side. I have cancelled the specific heat capacity since the material remains the same and it is water only. So I have cancelled the specific heat capacity on both the sides. So C has got cancelled. M suffix C, that is mass of cold body, I have substituted as 600 because it is given in the question. You can see here TF is X plus 15, that is final temperature, minus TC, we have assumed it to be X, so I have written it as minus X, is equal to 300, that is mass of hot body, it is again given in the question, bracket of TH, that is temperature of hot body, again given in the question as 50 degrees Celsius, you can see here or here, minus final temperature is x plus 15. So 300 and 600 I cancel, so it happens to be 2 times. Plus x and minus x cancels. So we get 2 into 15, that is 30. And here what we have is 50 minus x minus 15. So 50 minus 15 gives me 35 and minus x remains as it is. Now minus x goes to the other side and 30 comes to this side, that is right hand side. We get x is equal to 35 minus 30. So x is equal to 5 degree Celsius. So final temperature is 5 degree Celsius. If the question asks you to find, the initial temperature is 5 degrees Celsius. Final temperature will be 5 plus 15, that is 20 degrees Celsius. So coming to question number 13 of Calorimetry exercise 11A ICSE 10th. 1 kg of water is contained in a 1.25 kilowatt kettle. Mass of water is given 1 kg. Power of the kettle is given as 1.25 kilowatt. Calculate the time taken for the temperature of water to rise from 25 degrees Celsius to its boiling point of 100 degrees Celsius. Specific heat capacity is given in joules per gram per Kelvin, that is 4.2 joules per gram per Kelvin. So coming here, 4.2 joules per gram per Kelvin, I need to convert it to joules per kg per Kelvin because here the mass is given in kg. So I have converted it, that is 4200 joules per kg per Kelvin. You just need to multiply by 1000 when you convert from joules per gram per Kelvin to joules per kg per Kelvin. And if you are converting from joules per kg per Kelvin to joules per gram per Kelvin, you have to divide by 1000. Delta T, that is change in temperature, is 100 minus 25, that is final temperature minus initial temperature. So that gives me 75 degrees Celsius. Mass is 1 kg as it is given in the question. Power is 1.25 kilowatt, that is we multiply by 1000, we get it as 1250 watt. So we know the formula Q is equal to MC delta T. Now Q can be written as P into T because work done divided by time is nothing but power. So power into time is nothing but work done, which is nothing but heat. So power into time is equal to MC delta T. Power is given as 1250 into time we need to find out is equal to mass is given as 1 into specific heat capacity is given as 4200 into delta T, we found it out to be 75. So I multiply 4200 into 75, it gives me 3,15,000, and this 1250 comes to the denominator, so we get it in the denominator. After doing the calculation, I get the time to be 252 seconds. You can definitely leave it here, but as I say, the textbook answer is given in minutes, so I have converted it into minutes. So the way we do it is 252 divided by 60, so that gives me 4.2. So that is 4 minutes and 0.2 minutes. Now 0.2 minute I multiply by 60. So 0.2 into 60 gives me 12. So 4 minute and 12 seconds. Hope you guys have liked the video and consider subscribing to the channel. Do share it with your friends. Thank you. See you in the next video of calorimetry.